Today we will continue assembling the blower. I have printed the parts and I will also clean the other one. So here are the little legs. No. So much for them. So here are the little legs that are new, and we have the chimney here with a piece of the build plate onto it, stuck onto it, and yeah, I basically broke up the pay, which is not a good thing. I might will need to do something about it, or the other thing is that I will remove the whole thing and then just call it garbage and then replace it with the glass one, because I have a glass one for backup, thank God. So yeah, I will start working quick. In a second, put this shit away that I don't need. Alright. My best. Alright. Just gonna make a quick tidy up so that I will be able to start putting things together. Alright, we have a bit more space here. Okay. Yeah, I would definitely need some, I don't know what, a charger. So, to charge the phone. This has like some really trash battery. Alright. Alright, I will put this aside. And oopsie doopsie. I mean, it's probably pretty unnecessary to. There are pieces of this pay material here that I can spot and I will take out. I want to reuse these waste. I will. So what do we do now? And first I will clean up this because that's the boring part. We need my Russian cell here. Take the pay off somehow. Then, I mean, it comes easily off. And they said that it came off the build plate. Unfortunately, this did not remain on the build plate. It was very stuck to the build plate. When I actually chiseled the part of it, then it came off with it. Unlucky. Whatever. That's not too good, but yes. It's expected, kinda, you know. We actually learned this about in school. I think it was called the total cost of aircrafts. Basically, I'm in university learning about aircrafts and designing aircrafts and vehicle engineering, whatever. So, vehicle engineering's one part is actually estimating total lifetime costs. And one thing that people, I mean, myself included or excluding, that I didn't think about, yeah, that the aircraft can be more expensive. They say something like along the lines as um, cheap woman can be expensive or something like that. Basically, if you buy like a cheap aircraft or whatever 3D printer, if you expect it to go forever without any part breaking, then you are either very ignorant and you don't know jack shit, or you are just I don't know, delusional, because everything will break. Even the best printers will have parts that break, because that's the way of the universe. Nothing lasts forever. Everything has its life expectancy. Some parts die sooner than others because they are not as well engineered, maybe. But I can't really talk about, um, printers, because I don't know much about them. Because there is two things. One, that they are expensive because they are really well engineered, all that kind of stuff, or just expensive because they have like the good old fashioned, how do you call this, the monopoly situation, when they can charge whatever the fuck price they want. I don't know, I wanted to talk about like Bambu Lab, if that's like, I mean, I heard about it, that it is like pretty expensive and pretty well known, but I don't know if it is any good. I mean, yeah, sure, if it is like good in the sense that, yeah, people hype about it, but like, is it good in like a Ferrari sense, that it might be good to use and fun to use, but will it break down and then die? Or is it like a Toyota, that it might be a bit shittier experience to use, but still is going to last for a long time? And that's the difference. And back to the point that I was wanting to make, that everything will break down, every single piece of equipment will break down, whether it be a 3D printer, an aircraft, or whatever the fuck, it will break down sooner or later, and depending on the design and how well it was done, I mean the designing. And um, you need to calculate the whole life cycle, so that you basically, I should have put a chamfer here. So you need to calculate these reoccurring maintenances, parts missing, parts getting, like they breaking down, all that stuff. Because I don't know about these, but I assume that I will have to get, I will have to know more about this, because I don't know that much. But I assume that they don't really, have maintenance manuals and all that kind of stuff for like 3D printers, to say that, say, if you build a print for 100 hours, then you should, I don't know, grease the main screw or lead screw, whatever, Z screw. You get the point. In my printer, or on my printer, I bought this second hand, so it might be in the document, I have no fucking clue, we have to check. So cleaning this shit off and then going to assemble the two halves. First try on the chimney, and if it is fitting nicely, then I will I hope it will fit nicely. Taking off the edge here so that it might fit better, hopefully. And these lips are sort of necessary because you want them to be kind of centered, which is very important for these kind of things. Even if they don't seem to matter that much. Yeah, what would it... This little chimney here gives you plus 10 to 15% of plus air that you can move with the blower at the same exact amount of power. So it is very useful, I would say. I would add. It is very useful because it reduces the turbulence that the swirling causes when it sucks the air in at the inlet. Without the chimney, it would actually draw the... I'll show you in a second. Might will need to, I don't know, somehow get the because I have actually put like a rounding on this. Maybe I should have put a bigger one. I think this got not too bad, too good in terms of the printer did not do this too well. Alright, so this is the bottom, this is the top half. Now here comes the moment of truth. Does it fit? Does it not? Oh yeah, it does fit. It does fit. Alright, great. Alright, great. It might have it might fuck. So it does fit. There is not too much on it. So it does fit, which is a great thing. The other thing that I will have to now do is that I will have to put the screws in from here. And that will be easier than yesterday with the legs and today with the other legs, because I will have to do it. Alright. 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 Okay. I have did these inner holes so that, how to say this, slotted holes, so that the air as it travels, it doesn't hit the air doesn't hit the things, so they don't protrude in actually. So yeah, this is nice and ready. We'll have to take the legs off of here and we'll have to put the new legs on, which I have just finished. kind of feels like Lego again, that I'm just building bigger things and put on the goggles. Don't want any bullshit to happen. Oopsie doopsie. Alright, one is off. Second is off. And here comes the last one. Alright. So let's go step by step. Step by step. Oh, no good. Not good. Step by step. Oh, anyway. Very fuck off. The straight is, yeah, I won't call the straight. Fuck off. Alright, the first leg is done. Great. We have now something to rest this shit next to so it doesn't wanna fall. Oh fuck me, something broke. Oh my god. Overdone the tightening. I will have to add like a, I think it will work. I will have to add a little clip. We have these little metal clips that we can basically put into them that hold them together. You basically melt it inside. Well, thank God I was so fucking brain dead that I I was so fucking brain dead that I put the old one for some reason. I don't know. Alright, thank God. Okay, so focus. Don't over tighten it. Alright. Okay, and the last one. I will take the camera a bit closer to my shelf because I do not care about him now. I will need a new see. Fuck off. Did I screw it in? Oh, I screwed it in the wrong way. Alright then. Hope this is okay. Pretty tight. Alright. We'll have to see a bit. I mean, they flex a bit, so that's at least a good thing. So yeah, here are the two halves, and this is going to be the bottom, right? And I will need to put the blower onto the bottom. So which one is the bottom? This. So basically this goes over here, which is a lot better now that it actually, which one is which? Who is who? Actually, this is this, or yeah, we can go with this. Alright, great. I will put this on. So now it does not touch the thing, and this will elevate the whole thing from the base plate, and now it will have a nice clearance. Great, actually it is very well. This is what I wanted. So what I will do now is that I don't need this. I will flip the whole thing, flip the script, and then assemble the guy the other way around, and put this one on the legs. I really hope I will be able to put it into the middle. Where's my bag? Yeah, I'm a bag of screws. Bag of screws. Great. Alright, it's fine for now. I will not tighten it totally. Hopefully they will be able to flex all. Okay, and the last one, which will be this. Don't want to break anything. So actually this ring is not there to hold the whole thing, it's just there to position it and to space it with the little legs. Even this shit is failing. Alright. Whatever. So, yes, this is tight. Pretty tight, pretty tight. Great. I don't know if it is centered. It looks pretty centered to me. We'll see. I might well need to reprint this part. Alright, put on the... unfortunately the guy is not here from yesterday. However, he would have been very happy to see this finally come to fruition, which is what we actually wanted. Where the fuck is the glue? Alright. Alright, okay, alright, okay. So, alright. Yeah, 2-3 millimeters is pretty lower clearance. And imagine in like jet engines and turbines, they have like sub-millimeter clearance and tolerances. I mean, probably they have greater than that, because when you have the thing very cold, I mean, I probably shouldn't tighten this already. When you have the, let's say, the compressor of a jet engine cold, it will heat up when it is working, and the parts will get bigger basically because of thermal expansion, and you want some clearance so that they can basically get larger. And even centrifugal force, I mean, compressors don't really get that much hotter. Turbines do, because they run at like 1400 Celsius or something like that for basically forever, and when they are operating, so they run on that, as well as centrifugal forces do like draw out, as the force like draws the whole thing, they expand a bit towards the edges, as they call it radially, to be more precise. There's a bit of wiggle. I don't like this. Not too much, but I think half a millimeter or 1 millimeter is there with play. I don't like that, to be honest. Don't like it that much. We have assembled the top as well. Unfortunately, nobody is here to say this, but if you want this back, then props to you. So, alright, we used 6 screws for the, I will make screws for these, or not screws, like little, I don't know, something that you can put on over them. It's like a cap or something, so that they don't, you don't hurt yourself, or you don't accidentally do some bullshit. You get the point. Your clothes don't catch it or something. Don't. Alright. Clipping the whole guy together. I think, yeah, this is another one. I think we did this, we did this. Alright, and we did this as well. So much so for the goggles. another screw here. Right, I think we put one here as well. And I think I have only taken out 5, not 6. Which is not too good. Yeah, I need one more. Alright. I am pretty happy because we have actually made this shit. We'll test it. Doesn't touch to the wall, it seems. How lovely. We have built the whole goddamn thing. Now we might as well test it. Hopefully it will not fall apart from the load. We'll see how it does. I will take the camera with me. Sorry. Oh, where should I put this? Maybe here, maybe here. So I will hook it up. You can see the wires here. Yesterday I talked about this bit because you need like a forward versus a backward blade, and when you have it wired in the other way around than it's supposed to, it's not going to be forward bladed but backward bladed as it's supposed to be, and how it was designed. I almost fucked it up because here's the debris. I will put the cap on it so it doesn't blow it all apart if there is any dust and all this shit will not be blow apart. So yeah, let's turn this on, shall we? So 8 volts, 8. Pretty serious. Yeah, I will have to hold it down. It's pretty powerful, I'm gonna lie. If I can take this foil shit, put it under it because it wants to vibrate on the floor. Put it fucking wires all over the place. There's a bit of wiggle when it starts, you can see that it's shaking. But then it starts. It vibrates pretty badly. And it is leaking around, leaking out on the edges, I sense. It's a lot. Yeah. Pretty nice. I think the imbalance is causing it to vibrate a bit, but I think at like 8 volts, let's go to 7. It's not that bad. It's still shaky. It's still shaky, but man, the impeller is like 280, 200, 220 grams ish. So no wonder why it's shaking. Might be a bit of imbalance. But this is still a lot. Does it? It doesn't blow this aside, but something. We have like a bag. You can't. This is not too good because you can't really tell from the video. It's pretty strong. It's working as how it's supposed to. I'm pretty happy with that. I will need to seal the two halves all around, and the other thing is that somehow I would need to make the bottom part so it doesn't leak the air, because I'm pretty sure that the bottom leaks a lot of air. We'll see, but I think that's the case. Actually, it isn't. It's leaking some, but it's not that dramatic. Maybe the motor's moving part, the armature is drawing it in, because that's why it isn't like sensible here. But no, it isn't. Maybe I will add some extra sealing things here so that it doesn't do that. Interesting. I will need to add a bit of sealant between the two halves, and then it would be even better. I will set up the testing rig for the other blower and see how much air I'm actually being able to blow through the this measuring device here. You can't see that measuring device there, so I will test that. I think I will take a coffee break and do the job after that. And another thing is that I will need to take the top off. This chimney needs to be addressed in that sense that one way it needs to be sealed, but the second, which is more important, is that I will need to add a radius, a vetter radius onto the edge of the inlet, because that helps the maybe this is too small of a maybe this is too small of a chimney. I'm actually thinking about that. I will add the radius to the inner one, so basically the edge that actually sits just above. Mindjárt! Just above this. Okay, so my mom left. Now, now I will be able to. I think I will take a break now, and I will start a new stream, and then we will assemble the testing rig and the testing line of the whole thing. Add the fuck it, put myself on the put myself on here. So so I will now move on and assemble the guy, this one, this rim, this measuring rim, this with orifice plate, so that we will be able to measure out the pressure difference between the two lines, which will be used to actually will be actually used to measure the amount of air that we provide through this. And I will make a device. I will just design it now so that I will be able to fit the motor, this one, the blower that we have just assembled. We will be able to connect this to the green rim that you have just seen, and yeah, this will be, yeah, I'm pretty happy with this. Pretty happy with this. Blew very well. We have to see about the amount that it blew or blows actually, and all that kind of stuff. I'm curious to see. Maybe I will have to redesign the whole impeller or just clean it up, whatever. We'll have to seal it regardless and have to like sandpaper the inner rim to make it radial. But yeah, I will just hop onto the computer, design the part that actually sits in between the green and the purple parts, so that it expands the exit nozzle, because it's 45 millimeters now. The green one was 57 in our diameter, so they both are fitting each other nicely. And then I will I mean, it will be kind of like this. This is just for the other thing, this is just for the other part, this is for the air gun, for the oil gun, the spraying systems to measure how much air we are using for the atomizing of the oil that we will burn. This is from PLA. Maybe I will swap the spool back to PLA, because I still have that and it will be perfectly fine for this reason, for this job. Although it might be a bit messy, so I might not do it. Maybe I will. Whatever. Well, that's a topic for another discussion. So I think this was it for this part today, but I will, as said, come back and continue the work. So see you then, do the artwork, especially when you don't feel like it. Miss Winger is out.